For problem 3C, we need to find the instantaneous rate of cooling at 2 minutes. So let's go ahead and find 2 minutes on our graph. So minutes is on the x-axis, so here's 2. We go up to this point right here. Now we want the instantaneous, okay, which means the exact value, or you can think about it as tangent. So we want this guy right here. And that didn't draw very well. Let me try it again. Yeah, it's a little bit better. So the instantaneous rate of change is like the average rate of change, but the difference is the following. So, okay, let's write this down. An average rate of change, that is between 2 points. So that is the slope between 2 points. An instantaneous rate of change that is the slope at 1 point. And when we think about the slope at a single point, we're thinking about the tangent line. So what we need to do is we need to somehow estimate this slope right here. So we need to estimate the slope of that line. Okay. Now how are we going to do that? Well, there's a couple ways that we could do it. We could pick a second point that's a little bit off of that point, and then we can find the slope between those two guys. So let's say we picked this point right here. We could find the slope between those two guys, and that would be a good approximation for that slope. Okay. The other thing that we could do is we could actually use our line right here and see if we can't estimate just with this line. So what I'm going to do is I'm going to try that route. I'm going to go ahead and I'm going to extend that out as best I can. Okay, so it's pretty good. Okay, I know it's not perfect there, but if you look, it looks like at 2 we're maybe up here at a height of, now let's go ahead and count these. This looks like it's 120, and so maybe, I don't know, I'm gonna guess at that and say maybe about 123 degrees Fahrenheit. And then, of course, we know that that comes down to a value of 2. So, at 2 minutes, we're at 123. Now, what we can do is we grab another point on that line. It looks like right here, okay, right in this area. So it would be at 3 minutes over. It looks like I'm at a height of 110. So at 3 minutes, it looks like a height of 110. Again, this is an approximation because we don't, as of right now, we don't have any other tools to use for finding that exact value. So let's go ahead and find this slope. So we're going to have 110 minus 123. Okay, so 110 minus 123 over 3 minus 2. So this would be a negative 13 over 1, which is negative 13, but let's be careful on the units. Okay, so yes, it's great that negative 13 is a number, but if you can't apply that number to anything, then there's really no point in doing any of this. Okay, it's not about getting the number at the end, it's about understanding what the number means. So this negative 13 is degrees per minute. So we have negative 13 degrees Fahrenheit per 1 minute. So the rate of change at 2 is negative 13 degrees per minute, or we're cooling off by 13 degrees per minute at time 2. Now, of course, that will change depending on what other time we're at. For example, if we were at time 1, it's a little bit steeper there. So if I look here at time 1, the tangent line is a little bit steeper. So we'd expect this value to be a little bit higher. When I say higher, I mean more negative. So maybe negative 14 or negative 15 degrees per minute. Now, if we're over here at, say, time 5, the slope of the tangent line is flatter. Okay, so we have to take that into consideration.